Hello, math humans. We're going to do 8.3 today. We're going to be talking about the inverse of a square matrix. So our objectives are that we're going to find the determinant of a 2 by 2. We're going to find the inverse of a square matrix. You will never be asked to find the inverse of a non-square matrix by hand. And then we're going to verify that matrices are inverses of each other. So let's start by talking about a matrix equation. And a matrix equation might be one where you have capital A times X is equal to B. So if this were regular algebra, like AX equals B, then I could just divide by A. But in matrices, there is no division. So the only math operation that I have that resembles division is multiplication. So X is going to equal the inverse of A times B. And the inverse always has to come first. Okay? You can't do it in the reverse order because you will get the wrong answer. So X is going to equal the inverse of A times B. So if you're solving a matrix equation in your calculator, there's an inverse button on your calculator, right? It's this cute little button right here, raise something to the -1, that's the inverse button. So I can actually do the work in my calculator, but I need to be able to do it by hand because some matrices aren't able to go into a calculator, especially if they include variables. So if I want to calculate the inverse of a square matrix, and then again, I'm not going to ask you to do the inverse of a non-square matrix. Okay, so the inverse of a square matrix, so let's say A is going to be A, B, C, and D. Then the inverse of A is going to equal 1 over A times D minus C times B. Okay, all right, this particular portion is called the determinant. And an inverse isn't possible if the determinant is 0. So the determinant can't equal 0 because then the world would explode. And then you're going to multiply, and I'm going to move things around. So D and A are going to trade places, and C and B are going to become negative. Okay, so notice that A and D traded places, and C and B became negative. Okay. So sometimes in problems in the text, you're going to be asked to find the determinant, and this portion is the determinant, okay? Alrighty. And then sometimes you're going to be asked to find the inverse, and if I do, it's 1 over the determinant, and then I rearrange the pieces on the inside, okay? So let's do our first example. So example number 1, you're going to be asked to find the inverse, and you're going to be given that A is 3, -1, -2, 2. Okay, so yes, I could do this in my calculator, but we're going to do it by hand. So the inverse of A is equal to 1 over this product minus this product. So it's going to be 3 times 2 minus, sorry, I had a brain fart, a -2 times a -1, which is positive. And then I'm going to rearrange the elements on the inside. So this is 2 and this is 3, and then these guys change signs, okay? So this is 1 over 6 minus 2 times 2, 1, 2, 3. The determinant is a scalar, right? So this is 1/4 times 2, 1, 2, 3. So then this becomes, scoop my paper up so you can see, 2 over 4, 1 over 4, 2 over 4, and 3 over 4. We always have to reduce our fractions, so I'm going to write the inverse of A is equal to 1/2, 1/4, 1/2, and 3/4. And that would be the inverse of A, okay? So let me show you that in your calculator, okay? So I'm going to go in, if I hit the right button, I'm going to edit A. A is a 2 by 2, and our matrix was 3, -1, -2, and 2. Okay? So then if I quit and I do second matrix and I do A and I raise it to the inverse, then notice that I get decimals. If I want to, I can math frac my matrix, and now you can see that I have my fractional answers. Okay? All right, let's do example number 2. So example number 2, I want to find the inverse of B, and B is going to equal 3, -1, -6, 2. So the determinant, remember, is this product minus this product. So it's going to be 3 times 2 minus 6 times 1. These guys are both negative, but a negative times a negative is a positive. But notice we have a problem because I have 6 minus 6 is 0, sad day. Therefore, when I try to do my inverse, it's 1 over the determinant times 2, 3, 6, and 1. It is not possible. So there are times when you can't take the inverse because the determinant is 0. We can't divide by 0 because the world would explode. Okay? All right. Now we're going to talk about solving equations using inverse matrices. So if I have a system of equations, okay, so I want to solve a system, my preference is always going to be RREF because it's significantly faster. But I can also solve a system using inverse matrices. So let's say I have the system, this is going to be example number 3. I have the system x minus 2y is equal to 0 and 2x minus 3y is equal to 3, and I want to solve the system. This time, because I want to illustrate how to do the math, I'm going to solve it by inverse matrices. So I'm going to have the coefficients, so 1, -2, 2, -3. This is called the coefficient matrix. Then I'm going to have a variable matrix, and my matrices or my variables are x and y. And then I'm going to have my solutions. And notice that everything has to stay in the precise order. Okay, so this is the variable matrix, and this is the solution matrix. And I typically call this A, and I call this B. And then I'm going to label this X just to be a generic variable. So then I have the equation AX is equal to B. X is going to equal the inverse of A times B. And it makes absolutely no sense to do this math by hand. So I would do all of this in your grapher. And if you do, you're going to get that XY, or your X matrix, is equal to 6, 3, which means that X is equal to 6 and Y is equal to 3. Alrighty, and then remember that we report XY is equal to 6, 3. Just to remind you, if I had been solving the system, I would have done it with RREF. And we've talked about this before, and we've used this before, but I would have made 1 minus 2, 0, 2, -3, 3. Technically, this is called the augmented matrix because the solutions are inside the matrix. I would have done RREF in my calculator, and then I would have gotten my solutions. So this is my preferred method of solving systems of equations, but we always like to have lots of tools in our toolbox in the event that for reason the RREF didn't work. Okay. The next thing that we're going to talk about is verifying inverses. And particularly, we're talking about inverses of matrices. Sorry, it's been a long day today. All right, so if two matrices are inverses of each other, their product, A times B, is going to equal I, which is an identity matrix. And that means that B times A is also I. Okay? So remember when we did functions and we wanted to verify inverses, we would do a composition. So for functions, the rules were a little bit different. F of g of x would give you x, and g of f of x would also give you x. But for matrices, we are looking for a product that yields an identity matrix. So for our next example, example number 4, it says verify that A and B are inverses. And so I'm going to do that math by doing calculator work. So I have 1, -1, -1, 2, and I have B is equal to 2, 1, 1, 1. And in my grapher, I want to show that AB is equal to an identity matrix. So I'm going to get out my handy-dandy grapher, okay, and I'm going to put it over here so you can see. So I'm going to quit, and I'm going to go into matrix, and I'm going to edit A. It's a 2 by 2, and my A is 1, -1, -1, 2. And then I'm going to go into, I want to edit matrix B. It's also a 2 by 2, and his elements are 2, 1, 1, and 1. Okay, I'm going to quit. I'm going to do matrix A multiplied by matrix B, and notice that I got the identity matrix. So I would say that A times B is equal to 1, 0, 0, 1, which is the identity matrix. Therefore, A and B are inverses. Okay? Because remember, we always have to answer the question that's asked. And then I can do the vice versa. I'm going to do B times A, right? So I'm going to do second matrix B times second matrix A. And notice that I also get the identity matrix. So your calculators are wonderful because they can show you a lot of information. Alrighty? You will not be asked to do this by hand, although it is an entertaining practice. Alright, that is it for today. I will see you soon.